question 2C, we have a similar sort of question. It says, what's the chance it has a G fault given that it does not show F2? So we've actually got to begin by working out the probability we don't get an F2. Okay, so that we could do either by going through all of the different ways we can not have an F2, which would be CF1, CF3, GF1, GF3, NF1, NF3. Or you could do it as 1 minus the probability that you do have an F2, which is 1 minus 3 branches, so slightly quicker. Okay, so an F2 fault, you could have a C followed by F2, you could have a G followed by F2, and you could have an N followed by F2. Okay, if you work out 1 minus all of those, you'll end up with your answer. Let's just see what that comes to. 1 minus 0.08 minus 0.35 times 0.05 minus 0.25 times 0.85. So that gives you 0.69. So that's the chance of not being an F2. Okay. Then we want to do the conditional. So we want the probability that we're a G given that we are not an F2. Okay. So we need to think about the ways that we can be a G and not an F2. And then divide that by the probability we're not an F2. Okay, so I'll refer back to my tree diagram again. The way I can be a G and not an F2 is if I'm a G and an F1, or I could be a G and an F3. And then I'll divide that by the chance I was not an F2. Okay, so 0.35 times 0.3 plus 0.35 times 0.65. Obviously you could lump them together and say it's 0.35 times 0.95. Divide that by your 0.69 and you get, as a fraction, 133 over 276, which is the same as 0.482 roughly. There's various ways that you might have got to that answer. You might not have done exactly the same way as me, but you should agree with the answer at the end.